Before I introduce our next and final speaker, what do you think? Is she going to have a word count in her slides? Yeah? How many of you think yes? Okay. All right, we are in for a treat. So our next speaker, Sean Hay. Sean is a senior data visualization engineer at Uber. She's a coder, a designer, and a data artist. Sean is the founding member of Uber's data visualization team. At Uber, she builds data tools and platforms to make business intelligence easy to access, creates exploratory data visualizations to facilitate data analysis and modeling. So you're really in for a treat. There's a lot of cool moving parts that's going to be on the screen shortly. And prior to joining Uber, Sean studied at MIT and received a master's in design computation while conducting research at the MIT Sensible City Lab as data visualization specialist. Her work was exhibited at Milan Design Week in 2013, Google I/O in 2013, and Venice in 2014. So let's welcome Sean He.
And then at one point, you're like, OK, so what does data visualization do? And people come to me saying, oh, do you plot charts, or you do infographic, or do you do like dashboards? Usually the answer is yes to all. And just because data visualization is actually really expertise where we just help people better see their data, and then we do all kinds of, we have all kinds of design and self-engineer that working in this domain. So today I'm going to, for those of you who may not know what data visualization is, I'm going to do a little bit introduction. I will also go through some of the working process that how a visualization expertise work. And then I will show some of the work we do, and in the end, I will also show one of the tools actually we build to help people better visualize their data. A little bit about myself. I'm a senior data visual engineer at Uber. My background is actually in architecture, the one that actually designed buildings. The funny thing is, when I graduated from architecture background with a computer science degree, I put in the keyword self-engineering, architecture in a job search website, and then none of the result came out is about architecture. It's like software architecture, is that what you mean? So no, but sometimes when people ask me what I do, I say, oh, I like build visualizations. And sometimes I actually build tools to build visualizations, and one of the days I actually have to build tools to build visualizations. I mean, that's just what self-engineers do every day, right? So also, I actually use JavaScript for big data. Sorry, Holden. I literally added the slides when I was listening to your talk. So the reason is that if you want to visualize the data in an interactive way, many of the times you want some kind of web applications, and then that's the part that our expertise might actually come in handy. So we can talk after that. So at Uber, we have a lot of data we need to make sense of. So Uber's business is based on our data, which is one of our biggest assets. So the data visualization team actually have a lot of challenges. One of them being every day we're collecting millions of trips, billions of data points. How do we help our engineers and our PMs and our developers to make sense of what is actually behind it so that it can make our business better? So when it comes to visualization, people ask me why is it important. This is the example that I always like to show. One example is that when I first joined Uber, which was about 4 years ago, everyone is obsessed with numbers. They put as many zeros as they can, as many commas as they can in their reports, and everyone get excited just by seeing a number. So, and then they come to me saying, oh, hey, what can you do with this? So when I first joined, I try to make them realize how important visualization is by taking one of a day of trips in San Francisco, and then I made this map. So every single, actually, it would be better if you, I should have said that if you sit closer, it'll be better. But so every single line on this map is made of one single Uber trip. And then this is just one day. And you guys probably know San Francisco. You can probably tell that by the pattern, every Uber trip of just one day is cover every single street corner of San Francisco. And what's really interesting is that because those data are completely generated by our drivers by our trips. There's no like massage into it. It can show you a lot of information. One of them being that the reason this line is really, really bright other than the other one is because that's a highway. And a highway, you have more lanes, you have more cars. And once you have more lanes and more cars and more trips, you actually have the density of data points overlay on top here. That's why you get a lot more, a lot more contrast over there. And then another thing interesting I like to show is that, if you can see, I will share the deck in the end. So here, you actually have a lot of zigzags. The reason being because those where the FIDA is, you have a lot of tall buildings, and that causes the GPS to lose their accuracy. So the lines we can draw here is really noisy, but it's really valuable because then our engineer can actually go in to take a deep dive into that area to see which part we have more like GPS errors, and that's probably the part we actually have hard time to have a more smoother pickup experience. So yeah, so everyone's got so excited by looking at this map, like the San Francisco office literally printed out on their wall. So I began to do more. And this is New York. This is Mexico City. And this is my favorite map just because, this part, you don't have any straight lines, not because that's just how they build the city, but because those parts you have like contours, those are mountains. So you can't really build any straight line on mountains, but you can build roads that actually follow the curve and the hillside of mountain. And this is Paris, one of my favorite cities. And this is London. If you haven't been to London, this is really big. London is huge, and this map literally covers about 50 kilometers. I don't know the numbers. I should have. This map literally covers every single district of London. And then on top of that, making things move, I took that one day of London map. I actually made this animation where every single, moving lines is one trip. And then it's just one day. This is literally playing back 2016 of just a single moment of London. And then by looking at this, you kind of immediately, you have the idea of the scale, the operations. Instead of that, like many zero numbers, this kind of gives you a much clearer idea of what our data looks like. It's not the end of the presentation yet. So starting from there, the statement, at the visualization team, we actually make a lot of maps. We can, just because a lot of Uber's business is geospatial based. Oh yeah, so you remember I'm gonna talk about the tools? Yeah, so I'm gonna talk about it later. So we make maps just to gain insights from it, and we make a lot of maps. This is my favorite one. I actually made it by this is one I try to show how different regions of the city try to connect with each other. So I draw just one single line between the pickup and the drop-off of the trip instead of drawing the actual path. So by doing this, you kind of see like this kind of a center here. There's probably a satellite city, or that's the airport. That you kind of see how different part of the city connects to each other by just looking at this map. This is one I did for New York, trying to show the density of it. I actually add a third dimension, like 3D, to this map. And I actually have to replace the Uber data with taxi trips. But this kind of map we usually do try to just to show density. And I also have this map showing the actual GPS pings in Jakarta, but binned by about 100-meter circles. So the brighter the color is, the more dense the GPS ping is. And then this is one of my favorite, if you're not from New York, but like this NASA map, like it's called like the Dark Night, where they made this map of entire Earth, and then the lights being where the street lights are. So you're looking at the city from the space, and you kind of see the city lights up. So this map is actually made of all the Uber app activities in New York City in one day. And then, I call it like, Uber Dark Night. But, just by looking at it, you kind of already see the entire Manhattan Island is lined up, just because that's how many people are actually looking at the app and using it. And then this is actually what I'm trying to study. So I just really love maps. This is the one actually I got I mean, architecture, right? Like have something with like physical space. So this is the one I actually got street trees of San Francisco, of the San Francisco government open data portal. And then I draw like a kind of a density of where the most street trees are. And then this road immediately come up. I actually don't know the name of the road, but if you drive somewhere on Inner Sunset, that's where I have the most dense street trees. And then this is one of the contour map that I did just by drawing the hills, the contour lines of San Francisco. And this is where Twin Peak is. Yeah, Twin Peak. Okay, but this is going beyond beautiful visuals. This is where I drop the mic. So at this point you probably say, all she does is like drawing pretty maps. And then at the end of the day, what I actually hate the most is someone come to me saying, "Oh hi, I love your maps. Can I use it as my screensaver?" So I got that a lot. The reason being that I think visualization is not just about producing something pleasing and beautiful. It's actually about showing you something. You can actually, we try to help you seeing something you cannot see from the 0 and 1s. We try to help you that you can actually gain insights. You can find patterns. You can find anomalies. You can discover stories behind the data. So that's actually what I'm trying to say here. I can show you 12 maps and you got excited, but I really want to show you is actually how do we process this and create these maps, and in the end tell you something about the data. So we actually create visualizations to gain insights from data, but sometimes this process can be really painful. In theory, if you go walk through the office of Uber, you see some people with fancy maps, so you're like, oh, those people are from data visualization team, that's all they do. So in theory, you think what they do is they write code, they run it through like terminals, and then something nice just show up on the screen. But in reality, it's more like this. So 9 out of 10 times the code doesn't run, and then you try whole day looking at console errors, and then in the end, you're finally showing something on the screen, but you actually don't know what it means. So this is our day, actually, over and again. So design meaningful visualization always require a lot of trial and error. Usually a process will be, you have some idea, you draw some sketch, you build some mockups with like Photoshop, Illustrator, you prototype it, actually write small programs in JavaScript, just trying to see how it looks. And in the end, you make it into production. But in reality, you got stuck in this infinite loop over and over again. Sometimes you don't even get a production because there's just nothing there for you to show. You cannot fake it because it's all based on data. So an example of that whole over and over process, I'm going to show you a little bit of, show you this task that I got to create a visualization for Uber Pool. So the hypothesis of Uber Pool is kind of simple. You have less cars on the road when people pulling, and it's going to be more efficient. And then I take that hypothesis, I started my data collection. So I took 1 day of Uber Pool trips in San Francisco. And for all the people who pulled on single trips, I got the 2 start and 2 endpoints, and then ran it through OSM to try to get the routes, just so that I want to simulate that if those people didn't pull, they would write separately, what would the trips look like? And then I try to use a comparison, just so that I can do 2 visualizations side by side. Just maybe on the Uber Pool side, I will see some signals. So that's my kind of start process. So I start doing things. First, I collect a day of trips, and then I, run it through like OSM. I use Python, by the way, as well. So I did all the data massage and processing in Python, and then have them clean up to the way that I want. And then I started doing some, fun things. The first try I did is that, I like to make things move around. So basically, for those 2 data sets, all I did is that I just animate all the trips. I just have them move around the canvas. And then the result isn't that good. I thought I would see some on this side, it should be a lot of volume, other side should be less, but actually it doesn't show me that at all. And then now I think about it, the reason being that I'm only using single color. And if I have single color overlay on top of each other, one time, 100 times, they're still gonna look exactly the same. So if this didn't work, the second time I used a software called QGIS. Instead of drawing the path, I just grab all the GPS pings I can get from the two data sets, and then I plotted them, just static maps. Again, this doesn't look good. Like I cannot see any density. I know there's a lot of trips along the highways, but so is there. I just cannot see a signal there. So I have to go back to my sketchbook. I started thinking about, okay, what is the key difference between these two operations? And then if I find this key difference, I can use contract to make it more obvious. So the key difference, obvious, is traffic, right? On one side, you have twice the amount of cars. So maybe color is a better way to represent this. So what I did is that I basically write a Python script. I calculated for every 5 minutes how many trips is passing one single street segment. And then I aggregated and all the number of trips, cars on one single street segments, and then use a color scale to represent the numbers. And then I mapped the numbers back to my trips. So by doing that, I actually was able to paint maps like this using colors. So the darker it is, the less car it is, but the brighter it is, the more cars that they are on the single street segments. And then when I started seeing some of the difference contract, I applied the same to the other map. This become more promising to me because now you can see the difference where this part is light up more and this part is less. So I think using color is the right way to go. And then I started to play around with the scales. In the end, instead of using linear, I started using Jenkins natural breaks to calculate the color. And then in the end, I made a video again. I added motion to the static maps, as I always like to do. Now I can see a lot of difference here. So once I painted all my trips based on traffic volume, and then I started animating them, I got a really promising result. And this yeah.
How do you normalize for number of cars?
Basically, I merged both data sets together. So I'm not just normalizing within one. I merged two of them together and calculate the domain between, because I calculate the street segments, how many cars on there. So for each of the street segments, I calculate the domain.
Are there just more individual drivers than dual drivers?
There are more individual drivers, but before, that's the hypothesis of this visualization, right? Before, with all the other method, I wasn't able to see the signal. Okay. But now I use a color, I start animating them, I'll actually be able to see the difference. So, yeah. Okay. So see, this is the common process of geospatial visualization, where what we do is we got a bunch of data sets, we started processing them in like Python or Node, and then we apply all these different visualization encoding skills, where we choose different visualization layers, we choose colors, we apply scales, we choose different dimensions, and then in the end, we're able to get a set of different visualization by going through the steps over and over again. So the idea behind this is being, the whole Uber pool visualization probably took me 2 weeks of time. I used all different like D3, Canvas, QGIS, Python, all those tools. But in real life, we want everyone to be able to do this without actually have to know all this like JavaScripts, and we want people to actually quickly apply all this method in just one single tool, just so that they can quickly get some insight from it, and then move on to another data set, or actually go deeper into it once they see a signal. So job security aside, I don't want to spend all my 2 weeks in doing just one visualization, and we want everyone to be able to do the whole process without learning all these like different languages. So that's why we actually built this tool called Kepler.gl. Um, and all the maps I showed you before was actually made with this tool. So we built Kepler.gl so we can fast explore all the millions of geospatial data just in your browser. And it's basically have this, if you use ArcGIS or use Photoshop, it has this like layered approach where you throw your data set in. You can apply some of preset layers that we give you, like a hex bin or scatter plot, or even add 3D buildings to it. And then the idea is that you can apply different colors to your data sets, play around with the scales, play around with sizes, see which one that actually can show you more signal. And then it's WebGL based because anything big data on the browser need WebGL and GPU. You also have all the presets map visualization, so you don't have to write your own. And it actually does like client-side, on-the-fly geo-aggregations, like heat maps, hex binning, grids, things like that. So the idea is to make data-driven maps effortless, and anyone can have fun and play with geospatial data and create beautiful maps. So the basic flow is that you upload any kind of data set you have to the browser. Usually browser can handle up to like 500 to 1 gigabyte of data. Obviously, you do some cleanup before that. And then you apply the filters that the tool provides based on whatever data type you have. And then you are able to, actually have my own. And then you'll be able to create all these different map layers and then interact with it. So with that, you were able to, just with one single data set, you were able to create all different visualizations using all the presets functions. And then a little bit demo. Again, because I'm not doing real-time demo, just because I'm sharing the screen, recording my screen is gonna hurt the GPU. So I'm going through the couple of steps by, first I will show you how to upload data. Second, how to filtering. Three, interaction. I'll show a little bit of aggregation and then show you some layer types. So upload your data. So you probably know that most of the geospatial data come in CSVs, GeoJSON, KML, and shapefile. A sample CSV will look like this. You have all the rows. Each of the rows, in this case, is a trips in San Francisco. So each of the rows is just one single trip. And then you have some data types like timestamps, and geopoint, lat longs, and metadata, things like fair distance. So all you need to do is just drag and drop. You drag the CSV in there, and because we built to try to find geopoints from your data set, so we were able to find that you have this latitude long, beacon trip lat, beacon trip long. So we automatically draw the points for you. So those are 200,000 trips, and then those are the points each of the points is where the trip begins. And because it has this visualization channel, so you can play around, you can change the colors, change the size. And you can draw multiple layers at the same time. Right now, I'm showing both the begin trip and then the drop-off of where the trips are. And then I apply this blending method called additive, just so that the more dense it is, more lighter it is. And then keep in mind, this is 200,000 trips, and then 2 points per trip make it 400,000 points. So we'll be able to use, with WebGL, we're able to render like just 400 points on the map. And you can smoothly zoom in, zoom out, pretty easy. So, but this is just Photoshop, right? You don't just want to look at things on the map. You actually want to find something in it. So we have this function called filtering. So filtering is basically based on whatever data type you have in your CSV or columns. Like, we will automatically detect the data type. From CSV, everything's a string. So we actually parse all the strings and try to make sense of each columns. For like, if you have 2018, 10, where we think, oh, that's probably a time string. And you have something look like, San Francisco, 31 point something, 122 point something, oh, that's probably a point. So we were able to detect that and allow you to apply filters based on whatever type that we detect. In this case, I actually be able to apply like a time playback to my map because I have this column called begin trip timestamp. So let's play. So I open the map legend just so that you can see the blue is where the trip begins, and then the yellow is where the trip get dropped off. And then I open this time filtering. I was able to just drag, so I see a time window where the morning is. Oh, if I can. And then you, oh, I can, sorry. I was trying to post the video. So this is where about like in the morning between like 8 a.m. to 10 a.m., like the pattern become immediately very clear where the yellows are drop-offs, right? You have a lot of yellows around here, financial district, and then this is probably Uber headquarters, and Caltrain. And you have all the pickups, which is like spread out around this like Nob Hill Marina, and then this part. And then when I started playing back the entire day, by just looking at about 3-hour window and start this like time playback thing, you know, I can observe how this like color patterns start changing. And it's very, very obvious when it comes to about evening commute time. So yeah, so about right now, still there's a lot of, you know, blue become where the trip begins, where you have a lot of blue around Fendi, and then but yellows all around, you know, where you used to have all the pickups. So this is fun by just, you know, be able to actually filtering. I was able to just looking at different patterns based on time. Then I can just like drag it back to see the difference. And interaction. So this is fun. You know, one part of the big data visualization is that you can just see a static map, but if you want to actually drill down to every single data points, it becomes slower. You actually either write another query or you wait for like a couple of seconds for the map to update. But we were able to build with WebGL. We actually have all the like real-time interactions with every single data point. And then we also have this really nice tool called brushing, where you literally can update the map based on where your mouse position is. This is very interesting when I'm drawing this layer called arc, where previously I show you where each of the arc is connects the start and end of a trip. And then I just start drawing this arc layer of San Francisco. But at this moment, everything is kind of intermingled. You see there's like, you know, highlights around here, here. But if you want to actually looking at every like a little street corner or just one region of the city, you're not able to see where that one connects to. So we build this building this interaction called brushing. So you know, I spend a lot of time playing with colors, just because I want to make it like just more pleasing. But we have this interaction. It's gonna, you know, have your map set up, turn on this called brush. Now now when I mouse move over the maps, I was actually able to highlight the trips just start and end around my mouse position. Usually with just a static map, this kind of interaction is extremely hard, impossible to do, especially when you have 200,000 trips on a map. But with GPU calculation, we actually embed the calculation into your shaders, if you, into GPU calculations, so that you can have this just real time and you know, very responsive interaction with the data-driven maps. I was trying to find SFO, just because. You know, it's actually really, really obvious where, you know when you see where the transit hub is. So downtown San Francisco is a big hub, SFO is a big hub. And then all the trips start and end from SFO goes to all over the South Bay. But here is probably where Oakland Airport is. Yeah, so the brushing, we actually have, once you click, it freezes the brush. And then we have exports. All the data that's currently being filtered can be exported. It's actually pretty useful where people just want to, like, after they filter to a smaller set, they want to look at just that single set. And in the end, we have aggregations. How am I doing on time? Do I still have 5 more minutes? Okay, great. So aggregation is very important because up to now, everything I show you is every single trip, right? It's every single arc, every single point. But for you to study geospatial patterns or for trends, it's actually a lot better when you try to aggregate all the single points into some kind of a geospatial pattern. That's why we have this layer called grid and hex bin and heat map to allow you to actually aggregate based on single individual points. So I'm turning this trip scatter plot points into a hex bin heat map. So by just like changing the layer type, I was able to show this heat map. And then we allow you to actually changing the radius of your hex bin just so that based on the size of your map or how detailed you want looking at, we actually allow you to change the resolution of aggregation. And then if you know scale, right now I'm actually looking at color based on quantile scale, which is equal distance, equal size bin. But that's, I was actually trying to look for anomalies, so I changed the scale to a quantize, which is linear scale. In this case, once I change it to a linear scale, I actually be able to see where the highlights are, which is obviously in this case is downtown San Francisco. But you don't want to just see the obvious information, right? I have a lot of we have a lot of trip start and end from the international airport. That's why we have this function. You can add like a third dimension. You can actually filter the bins based on percentile, where where we have this percentile slider that allow you to actually wait. I'm changing the size of the bin just so that I can see what's underneath it. And then this part is very obvious because that's where the high density trip are. But once I kind of exclude them, I was able to swipe to slide on the percentile so that I only showing between like 0 to 90%, and then redistribute the color just so that you can actually, if you are actually interested in what's in the lower percentile distribution, will allow you to just filter out those outliers. And in the end, this is just going to be a quick, because we have a lot of GIS specialists that are interested in geospatial data visualization. We also have this support for all kinds of geospatial data set like shapefile and GeoJSON that we allow them to overlay like more geospatial information onto the map. This is where I just find as SF contour data sets where each of the lines one contour line. And then I was just able to, because we allow you to apply visual encoding into numbers, I was able to color the contour based on elevation because elevation is part of the field I have. And then once you apply color, it's become much obvious. Remember the whole Uber pool exercise where I have to write all different code? Was this I can just drag, based on traffic or based on things like that. Yeah, so this is the last one. And again, I was able to just apply filters to all my contours based on elevation, so I can see where the high elevation contours are. So by just dragging on this slider, I can see the map changings. Yeah, so the idea is that we want people to be able to draw maps without actually have to write any JavaScript. They just need to have data sets and then plug into it. So since I ran out of time, if you're interested, we actually use all these different libraries that we built, Kepler.gl. Two of them we actually wrote ourselves, like DeckGL and React Map.gl. Those are all WebGL-based libraries that we actually write by our team and now also open sourced. And yeah, so we're actually also going to open source Kepler.gl in April. So if you're interested in using it, you can try this link. We will have you come in to do beta testing. But in the end, Kepler.gl is just going to be an app that we serve and give you a link. You can play around with any kind of data sets you have. And in the end, about us, we're a team of 30 people. Now, even though when I started, it was just me, we all love Hotpot. And then we do it every 3 or 4 months. We do this family-style pictures all the time. Everyone's happy. And if you're interested in data visualization, come to talk to me after that. Yeah, that's it. Thank you. Yeah. There's no ceilings. Everything is just, so that's where the scale come in handy, right? If I do linear, you're not going to see much difference, but the scale applies actually Jenkins natural break, where you kind of be able to find the natural distribution and then calculate the color. Sorry, I didn't. Yes. Yeah, but this is 1 day of trip, so we kind of just think those anomalies will just be overlaid by the massive trends. Yeah, thank you.
All right. Well, so we learned today how to make big data fast. Thanks, Holden. How to get out of pickles from Anya when you get into errors and so forth, and how to make big data not only beautiful but also tell you stories. So I think that was quite an achievement, right? Let's give a big hand of applause to all our speakers. So I'd really like to thank you for coming here and being here so late. Hopefully all the topics were interesting and you learned a thing or two. I would like to thank our organizers for tonight, Jen and Jules and team. Just a last bit of announcement before y'all can take Uber home. So Databricks is hiring in every single role that you can imagine: engineering, product, marketing, sales, field engineering, and and visualizations. Yes. So if you're interested, we have our awesome recruiting team here. Would you please stand up? All right. I'm putting them on a spot, so or in a line. So we have Lucy, Priya, Tarun, Yvette, and Jessica. So these are our recruiters. If you're interested to learn about our positions, we also have them posted online. Please talk to them. They're going to be around for a bit. Or if you are in a hurry, get their contact information and exchange emails, and you can get that information that way as well. So thank you very much for coming. Really appreciate it. Cheers.